All right, so here's part two. Um, let's go ahead and get right into the notes. After watching that video, I'm going to go through kind of a lot about a lot of the things that he talked about in that video as well today, and just kind of make sure that I, how much background information you guys know. I didn't do a pre-test, so I'm not really 100% sure. Some of you probably know a lot about the atom and the periodic table. Some of you a little bit, and some of you not much at all. So even if you know a lot, take this seriously enough to make sure that you're going through and getting the information and reviewing and refreshing it just in case it's been a little bit since you've talked about it, okay, or since you studied it. So let's dive in here to the notes that you guys are going to copy onto your doc. All right. Now, remember, you're looking at the blanks, okay? And for those blanks, it might be a single word. It might be a phrase. It might be a whole definition. Pause as you need to go. The most effective way to go through notes as we do them with these videos is that you stay with me and you're typing about what I'm talking about. So if that means you have to stop and pause mid-slide or after every single bullet, do that. Okay, do that. It makes it much more effective for you to take in the information if you're hearing what I'm saying as you're typing it, not just sitting there typing as I just kind of go through this, and then you pause it at the end of the slide, and then you finish typing stuff. You might as well not have listened to me because you probably didn't hear a lot of what I was going through and explaining. So the atom is the smallest component of an element, having the chemical characteristics of that element. And so we'll kind of get into this a little bit more about the difference between an atom and an element, because sometimes people get confused with that. But the biggest thing is that when people talk about, well, what's the smallest thing? Well, technically the atom is the smallest whole piece of matter. If we start talking about the things that make up the atom or the things that make up those things, then we're starting to talk about these particles that are smaller than an atom and they're not a whole piece of the atom. Excuse me. A little tickle there from talking so much. Dry throat here. So anyways, that's the atom is the smallest whole piece of matter. Now an element is a little bit different than that, okay? But we'll get to that in a moment. Atoms are the basic building blocks of matter, and everything is matter, right? If it has mass, if it's a liquid, a solid, a gas, a plasma, a Bose-Einstein condensate, the fifth state of matter, all of those things are made of atoms, right? They're all made of atoms. An element, on the other hand, is a fundamental material. Let me move myself here a little bit. Oops, it's not going to let me because I'm in this other one. That's all right. Maybe this will move me. Oh, that just flops me. Here, I'll just exit out for a second. All right, an element is a fundamental material consisting of only one type of atom. So what we're going to go through and talk about to start are the basic characteristics that every atom has. So thusly, every element also has those characteristics. Okay? And then next week, we'll get into what makes it specifically an element compared to an atom. All right? And so elements are one type of atom, a single atom. So if I have oxygen, oxygen is an element. If I have one atom of oxygen, there are certain characteristics that oxygen atom has that's a little bit different than any other element. But then there are other characteristics that it has consistent with all the other ones. Like it has a nucleus, it has an electron cloud, it has protons, it has neutrons, it has electrons. Now, the number of those protons, neutrons, and electrons vary, which make it unique, which is why it's its own element. But we're going to start with just the atom and the parts of the atom. Okay, there we go, a little bit over 90 elements that occur naturally on Earth. They're just here. Okay, they're just here. They were here when our planet formed, and it's one of the reasons why our planet can support life. It's because of a lot of these elements that just occur naturally. Okay, and elements they combine with other elements to make compounds like water, H2O, and even those occur just naturally on Earth too. There's many of those that occur naturally that support living things here on our planet. Okay, subatomic particles. Let's see if I can get my camera back. There we go. Okay, subatomic particles. Come on. There we go. All right, so if it's a subatomic particle, these are the things that are smaller than an atom, which is why they're called subatomic, right? Smaller than, right? Like a subscript, the small little number beneath the big number. So protons. First of all, you have protons, they're positive, okay? It's easy. Positive starts with P. Protons start with P. Positive protons, alliteration. Boom, perfect, right? There's a little plus sign there to represent the positive. Okay, those are in the atom as well. We'll talk about their position here in a moment. Notice the size, okay? 1.673 times 10 to the negative 27th kilograms. So when you see 10 to the negative 27th, that's scientific notation. And for those of you that are unfamiliar with it or you don't remember, what that means is where this decimal point is right here, the real number of this is if I took this and I moved it 27 times, 27 places to the left. So it would be 0.00000, 26 zeros before I got to 1673. First of all, it's a lot of numbers to write, which is why they have scientific notation. But that's how tiny these things are. That's the proton. Okay. Another subatomic particle are the neutrons. Neutral neutrons. So that's easy as well, right? That also has some alliteration. The letter N neutral for neutral and the letter N for neutrons. Electrically neutral particles in the atom. And if you look, they're just about the identical mass. We're still talking super tiny, but they're about the same size. All right, here's where the alliterations end, okay? Negative electrons. And that's why sometimes people get confused because they go, oh, N, negative. Oh, neutrons, because N and N. No. Neutral neutrons, okay? Negative electrons. So if you want to do something with alliterations, the hint that sometimes I give students is evil electrons because they're negative, right? Evil electrons, negative. So you have these negatively charged particles in the atom, okay? Now, I want you to take a look at the mass size of an electron. Protons are tiny. Neutrons are tiny because we're talking about the things that make up atoms, and atoms themselves, like you saw in the video, super, super tiny. Electrons, way smaller than even the protons and the neutrons. Okay? Notice, it's 9.11, but notice the scientific notation. 10 to the negative 31st. So that's 4 more zeros added in there. So it's crazy how small the electrons are, even compared to protons and neutrons. And these are tiny to begin with because they make up the atom, and the atom is super tiny. Believe it or not, there are things that scientists have discovered that are even smaller than protons, neutrons, and electrons. They have these things called quarks. The electrons are made up of something else too. You can take a look, and if you want to search that up, you can find it. But protons and neutrons are made up of these tiny things called quarks. So quarks are kind of like the sub atomic particles, just like we have sub bullets when we do our notes, sub atomic particles, quarks. Okay, and who knows? As technology develops and stuff, maybe they'll find up things sub particles that make up quarks. Probably one day. Okay, so here's something different that we're going to do today. This is a tri-Venn diagram that is comparing protons, electrons, and neutrons to each other. On your document, I have a link that takes you to a Google Draw that you cannot edit. It is a view-only Google Draw. It is set up very much just like this. You'll notice that there are colored boxes in each of the portions where the circles overlap or if they're by themselves. When you click on those boxes, those are text boxes. Your job right now is to pause the video, go through, and copy this Venn diagram into that Venn diagram. And the way you're going to do that is you just make a copy of my Google Draw, since you can't edit it. Make a copy, fill it out, and then you can insert it back into your doc, because you're going to want to have it in your doc. That's going to make it easier when it comes to like open note tests and stuff. Instead of just having it as something separate that you would have to access, just put it right into your doc. You can either do a screenshot of it, or if you know how to insert a Google Draw in there, insert a Google Draw. But go ahead and pause this now, get all of that information into the Venn diagram. You cannot get full credit on your notes without having this Venn diagram completed in your class notes. Okay, let's keep going. Atomic structure. I'm going to move myself. Oh, I keep saying that. I can't move myself. All right, that's all right. You can see it here. All right, this is kind of important. Well, all the slides were, but if you're thinking about doing the extension activity, the extra credit about building a 3D model of the atom, obviously all the notes are going to be important for the information that you need. Here's a model of the atom right there in terms of a two-dimensional model, as it's just a diagram of what the current theory is of what the atom looks like. All right, in the center is the atomic nucleus. Okay? The nucleus is in the center, and there are two things inside the nucleus. You have protons, which are the positive protons, and you have the neutral neutrons. Protons and neutrons are in the nucleus. Okay, so that's here. It's kind of like ball here. It's right in the center. With that nucleus, because protons are positive, but neutrons have no charge, the overall charge of the center of the atom, the nucleus, is a positive charge. It's positively charged center of the atom because there's protons and neutrons, and so the protons don't get canceled out by anything because there's nothing to cancel them out because neutrons don't have a charge. All right, in the center with this atomic nucleus is a lot of weight. And if you remember the previous slide, well, even before that, not the Venn diagram, but the one before that, even as small as protons and neutrons are, they were still bigger than electrons. So if you have protons and neutrons in there together compared to not having the electrons, they're going to be somewhere else, then that means that most of the mass of the atom is there in the nucleus. Now, again, it's super small mass, but the relative amount of mass of that atom, most of it is in the center, okay? Now, in the center, though, the protons and the neutrons are condensed, okay? They are compacted in there. They are tight, like it shows there in the diagram right here. And so even though they take up most of the mass, they do not take up a lot of space. So there's very little volume of the atom there in the nucleus. All right, so let's move to the other region. So you have two regions of the atom. The first region is the nucleus. The second region is called the electron cloud. The electron cloud is outside of the nucleus. We call this model of the atom the electron cloud model because this is the newer version of how scientists believe that the electrons are flying around the nucleus. There's been other models. You can look them up. I'm not going to ask you about some of them, but there's been different versions of what the atom looks like, these different models. The current model is called the electron cloud model because of the belief of what's happening with the electrons. They believe it's the region outside the nucleus where all of the electrons are. So it's negatively charged because it's electrons. Electrons are evil, they're negative. And it's the opposite of the nucleus, okay? Because they're so small in terms of their mass, they contain very little mass out in this electron cloud, but they take up almost all of the space of the atom, right? Almost all of the volume. And he tried to give some analogies in that video to describe that to you guys. Now, what's crazy is in between these, right? In between these is actually empty space. And when we talk about empty space, we mean like nothing. It is not made of anything. Anything that has atoms, nothing. It is a vacuum. It is empty space. And sometimes that's really hard for us to understand because we're talking about something that's super small and there's this empty space between there. But that's what it is in between those electrons. Okay? Okay. That is the atomic structure. You have two regions, the nucleus, the electron cloud. In the nucleus, you have protons and neutrons. In the electron cloud, you have the electrons in empty space. The nucleus has most of the mass. The electron cloud has most of the volume of the atom. All right, and that's what all atoms have, no matter what element they are. They all have these characteristics. And then next week, we'll go into some of the differences when we start talking about the number of protons, neutrons, and electrons, atomic mass, some of these other things. Okay, great. I hope you guys have a good weekend and the rest of your week. I hope some of you decide to take advantage of that extension opportunity for the extra credit. Have some fun with it. Be creative with it. Have a good weekend. Bye.